This video will give a rough outline of the proof of the fundamental theorem of calculus. Now, of course, you will not have to use this every time you use the fundamental theorem of calculus. This is just showing the mathematical justification for this amazing theorem. So suppose we know that f of x is continuous on the interval from a to b. We also know that there's other function, capital F of x, which is the antiderivative of f, which is to say that the derivative of capital F of x equals f of x. And I've just written here what it means to be a derivative, just written it in terms of limit form. So we'll put that aside for a moment. We want an expression for the area under f of x, and of course this equals the definite integral from a to b of f of x dx. And of course we evaluate this integral in terms by a limit of the sum of Riemann rectangles. So the first thing I'm going to do in this limit as x goes to 0, I'm going to replace the f of x sub I with this expression, because really that's what f equals. F of x equals the derivative of capital F. And of course, since it's inside a limit going as delta x goes to 0 anyway, we can just completely substitute it with this expression. So we get f of x plus I plus delta x minus capital F of x sub I over delta x, this whole thing times delta x. But of course, the delta x's cancel. And so we just get those differences in capital F of x. Well, let's think about what that means. We still have a limit as x sub I goes to 0. What that would be is capital F of 2 minus capital of F of 1, f of 1, plus capital F of x sub 3 minus capital F of x sub 2, plus capital F of x plus 4 minus capital F of x sub 3, and then dot, 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 and of course it would go all the way up to x sub n minus capital F of n minus 1. Now, of course, what's going to happen here, if you notice, we have a plus f of x sub 2 and a minus f of x sub 2, so those are going to cancel. We have a plus f of x sub 3 and a minus f of x sub 3, so those two are going to cancel. And in fact, most of the terms in this sum are going to cancel, and the only two that are not going to cancel is the minus of the very first term and the positive of the very last term. And of course, what this is, x sub 1 is just a. And so what this is we have a minus f of x sub 1, that's a minus f of a, and then x sub n, the final term, is b. So that's f of b minus f of a. And of course, that has no dependence whatsoever on the limit of delta x going to 0. So we can remove the limit, and this is exactly the expression for the area. So this is a very rough proof of the fundamental theorem of calculus.